Good morning, everyone. Today I will be presenting our research on sustainable solar addressing the growing need for PV panel recycling, co-authored by Saeed Ahmad, Muhammad Qasim Rana, and myself, Dr. Tariq Umar. We will explore the key finding and application of our study on solar panel recycling, which is becoming an urgent issue with the rapid rise in global solar capacity. The expansion of solar panel is one of the most promising solutions to mitigate climate change. However, this growth has led to a growing environmental concern. What happens to solar panels when they reach the end of their life? In our research, we assess the landscape of solar panel recycling, focusing on regulatory framework, technology, and challenges. We aim to explore how we can create a sustainable circular system for PV panels and of life management. By 2050, millions of tons of end-of-life PV panel will be generated. If not recycled properly, these panels could contribute significantly to electronic waste, releasing hazardous materials such as lead and cadmium into the environment. On the positive side, recycling offers huge potential in shape of resource recovery. For example, valuable material like silicon, aluminum, and silver can be reused. Similarly, recycled materials reduce the energy required for the new panel, and it also contributes to uh, economic benefits, for example, job creation and innovation in the recycling industry. There are a lot of environmental benefits, for example, reduce emission and pollution, which is aligned with the Sustainable Development Goal number 12, which is responsible consumption, and also Sustainable Development Goal number 13, which is climate action. Our study uses a qualitative multiple case study approach to assess recycling practices in several countries. The countries included in our research are Germany, Japan, and United Kingdom. We also compare these countries with the broader regulatory framework of the European Union, United States, and Asia. Our data comes from secondary sources such as government reports, academic papers, industry white paper, and more. We applied thematic analysis to identify recurring patterns and themes such as policy effectiveness, technological barriers, and industry collaboration. In our research, we explore the regulatory frameworks in various regions. In the European Union, the Waste Electrical and Electronic Equipment Directive is the key regulatory that's required extended procedure responsibilities for recycling. In the United Kingdom, post-Brexit, the country has retained these principles but has some challenges in implementation, especially in terms of infrastructure. The United States has varying state level regulation, with California leading the charge in solar panel recycling efforts. Japan is pioneer in advanced recycling technologies using chemical processes for material recovery. These regions demonstrate different stages of regulatory maturities, and their policies provide valuable lessons for a global recycling strategy. One of the most promising areas in solar panel recycling is technology. Innovation in mechanical and chemical recycling processes have significantly improved material recovery rate from PV panels. In countries like Germany and Japan, recovery rates for materials like silicon and silver has improved dramatically, which is currently up to 95% recovery rate for silicon in Japan. However, the cost of recycling remain high, ranging between 225 to 325 US dollar per ton. Researchers are also working on making solar panel more modular and easier to disassemble, which would simplify the recycling process. These advancements are making the recycling process more cost effective and efficient, but there is still room for improvement. Let us compare how Germany, Japan, and the UK have approached PV recycling. In Germany, they have a structured policy-driven approach with strong enforcement of recycling law. Over 85% of PV panels are recycled with high efficiency in material recovery. Japan's focus has been on technological innovation where they are using advanced chemical techniques. Their recycling rates are around 65 to 70%, but the technology recover high purities material, especially silicon and silver. The UK unfortunately lags behind in enforcement and infrastructure. Only 35 to 45% of panels are recycled properly due to insufficient recycling facilities and weak policies enforcement. Despite the benefits, several key challenges hinder the widespread adoption of solar panel recycling. The first element is high recycling cost. Recycling is more expensive than landfill disposal, making it economical unfeasible without strong policies support. The second area is the limited infrastructure. Many countries lack the necessary recycling facilities, particularly in emerging markets. The third area is the public awareness. There is low awareness among residential and commercial users about the importance and availability of recycling programs. And the last area is the complexity in materials. Solar panels are made of diverse materials which require customized recycling technologies for different types of panel. To overcome these challenges, several strategies should be adopted. Financial incentives like tax credit or subsidies could make recycling more attractive to manufacturers and consumers. There's need to be a greater investment in recycling infrastructure globally, especially in regions with high solar energy adoption. Government must strengthen EPR's law and incentivize the use of recyclable materials in solar panel design. International cooperation is a key. Sharing technologies, research, and best practices will scale solutions. Our study concludes with several policies recommendation to improve solar panel recycling, strengthen EPR mandates globally to ensure manufacturers take responsibilities for the end of life of their products, harmonize international recycling standards to make processes more efficient across border, provide financial incentives for companies investing in recycling technologies and developing innovative recycling solutions, encourage collaboration between government, industries, and academia to foster research and technology transfer. In conclusion, solar panels recycling is not just an environmental necessity, but a huge opportunity for creating a more sustainable solar energy sector. By improving recycling technologies, strengthening policies, and raising public awareness, we can build a truly circular economy for solar panels. This will help us reduce environmental risk, conserve valuable resources, and support the transition to a cleaner, greener energy system. We must act now to ensure that solar energies remain sustainable throughout its entire life cycle. Thank you for your attention. I would now like to open the floor for any question or comment you may have. You can also reach out to me through my email, which you can see on the screen, and also through my social media, again, also available on the screen. Thank you.